The last comparing group technique we will work through together is the one-way ANOVA, one-way analysis of variance. Sometimes analysis of variance is referred to as ANOVA test. The one-way ANOVA is a more generalized case as a t-test. So a t-test has a very specific rule that your independent variable, that is the independent categorical variable, has only two categories. Where one-way ANOVA, you could have more than two categories with your independent variable. So you could have 3, you could have 4, you could have any number that is larger than 2. That's why sometimes the one-way ANOVA, the t-test is considered a very specific case of the ANOVA test. The one-way ANOVA is a f-test, which indicate the acceptance or rejection of a null hypothesis. But the idea is very similar to the t-test and chi-square test. We're actually looking for statistic significance, the probability or the p-value. One thing that is slightly more complicated of the one-way ANOVA test is the post hoc tests, which doesn't exist with t-test or chi-square test, because all those two are comparing basically across categories or across two categories. But because we have more than two categories in an independent variable with one-way ANOVA, the test result might be significant, which indicating difference among the groups of the independent variable. But because we have more than two groups, that difference may or may not exist between all the pairs of the categories of the independent variable, or just a few pairs of the categories of independent variable. I explain this with examples which will be easier to understand. So let's look at this example here. We basically have a independent variable which is age group 3, and we have the continuous dependent variable which is optimism score. So the research question here is the age group has an impact on the personal optimism score. It could be that a younger person are more optimistic, or senior groups of person are more optimistic. So the problem here is that if you have a significant test result, the difference might exist between group 1 and group 2, or group 2 and group 3, or among all these groups, that is 1 and 2, 2 and 3, and 1 and 3. And that is the case if you have 3 categories. If you have 4, then it might be 1 and 2, 2 and 3, 3 and 4, then 1 and 4, 1 and 3, 1 and 4, and 2 and 4. So it becomes more complicated to actually pinpoint where the difference actually lays. So that's why we need the post hoc test. Post hoc test is actually a way of looking at pairwise comparison among each of these categories and figure out between which and which category there's a difference. But bear in mind that a one-way ANOVA test is actually a inferential statistics that could be parametric or non-parametric. So still we need to examine the dependent variables distribution. Then if it's non-parametric instead of one-way ANOVA, we need to use Kruskal-Wallis test. And that will be the case. We'll examine the optimism scores distribution as well. And you could actually work with Kruskal-Wallis test in SPSS as well. Again, we've got a detailed walkthrough, but we do it together with SPSS with this hypothesis, with this assumption. Okay, so this is the complete data set. We're looking at age group 3 impact on optimism score. So let's examine the optimism scores distribution first. So we go to graphs, we go to legacy dialogues, and then what we're examining is the optimism score, so total optimism. Move it to the value test. Okay, so it's not perfect. It's better than the self-esteem, but it's not perfect. So, well, as I said, there are method to actually correct this kind of distribution to make it more normal distributed, but because the correction is out of the curriculum, in this case, we're going to treat it as not normally distributed. So essentially, we need to use Kruskal-Wallis test. But before we do that, let's assume that, again, it's a normal distribution. So if we use the bell-shaped curve, you can clearly see that it's missing the right-hand side of tail spot. Let's assume that it's a bell-shaped curve, and then we can actually run the one-way ANOVA. How to run one-way ANOVA? Go to Analyze, and one-way ANOVA is compare means, and at the bottom of compare means, you have one-way ANOVA. Click on that, and well, it says dependent list and factor, and dependent list here is the dependent variable. Our dependent variable is, of course, the total optimism score. Our independent variable in this case is age group 3. No need to define anything. You know, there are 3 groups. It's different from the t-test where you need to define those 2 groups. But importantly, we need to assign a post hoc test method to test the pairwise comparison. Click on post hoc, and the most often used post hoc test method is Tukey. For all the rest, they are, you know, there for specific cases when you have a smaller degree of freedom, for example, or other bias, but Tukey is the most commonly used one, and we use Tukey in this case, and the majority of the cases you just need to use the Tukey. The default significant level is at 0.05, which is 5. Click continue, and I don't need to change anything else. Of course, you could click on these things and check it out. You know, what's the options do you want to test for other things, but for now, I just click OK. So we've got 1, 2, 3 tables. We'll walk through all of them together. The first table here is the actual one-way ANOVA test. So this is the most important test, basically. And that p-value this time is here, marked as sig. And if you look at this number, it's actually 0.01. So our alpha value is 0.05. So this is indeed smaller than 0.05, which indicate that we accept the hypothesis that there is a difference between different age groups in terms of total optimism score. So we having a statistic significance here. The F-test value is this, but we're not worried too much about this. The next thing we need to know is, okay, I know that know that, let me come back to this. I know that among these three groups, there are differences in terms of optimism, but I don't know whether it's comparing young people to medium-aged, to middle-aged, or middle-aged to senior, or young people to senior. So how can I find out about that? We look at this multiple comparison post hoc test. Again, we have a significant level here, and this significant level is comparing the young with mid-aged and senior. Comparing the young with mid-aged and senior. Oh, you can see that it's not senior, it's 45. So um, this is not 60, it's actually 45 plus. So the group 1 is 18 to 29. It's just I have different categories, but 44. Okay. Okay. Right. So compare between the younger age and middle aged, it's not significant, but comparison between the young and well, 45 is not exactly senior, it's just a more mature group of people. You can see the significant difference here. And this is exactly the same, it's just comparing 45 against 18 to 29, 18 to 29 against 45, so it's basically repeating itself. So the significant lies between 18 and 29 group and the 45 group, and that significant level is even lower than the group significant level, because this is the reason behind why there is significance. And we could interpret the direction in a way that, okay, so compare young to old, it's an increase, but there's a minus value of the mean difference, which means the optimism level actually decrease. So it's the opposite way uh, between an increase and decrease. So older people has less optimism score than the young group of people. So that's how you interpret these two tables. The last table, well, you don't need to worry too much about it. Actually, it's a homogeneous subsets. For this specific case, you don't need to worry too much about it. But as we said already, it's hardly a normal distribution. So essentially what we need to use is Kruskal-Wallis test. So how to run a Kruskal-Wallis test? We go to analyze, we go to non-parametric test again, and instead of any of these, we go to legacy dialogues. Instead of 2 independent samples, we're using K independent samples this time. And you can see already Kruskal-Wallis is the default test method. Test variable is the dependent variable. So this time, in this case, it's the total optimism score. And we're looking at, age group 3. Define, I don't mind to define it. We have 3 groups, so the minimum is 1, the maximum is 3. Continue, and it's automatically, it's default selected Kruskal-Wallis. We don't need to change anything about the exact. Don't need to add on descriptives. Well, you should have run descriptives, previously. Click OK. Then what we care now is, okay, this is not comparing means, it compares mean ranks, but we don't care too much about it. What we need to care about is this one, this figure here. So again, this is the p-value. It's lower than 0.05, so it is indeed a significance. But the problem with Kruskal-Wallis is, first of all, it's difficult to interpret the value. So we don't have the f-test value anymore. As you can see here, that's the unit of deviation. What's the score deviate from one group to another? We don't have it here. We don't have the parameter. And also, there's no post hoc test. arranged. You could run post hoc test actually, but it's a separate process. It's not integrated within this command. So that's all we need to know about the ANOVA test. Before we conclude our teaching here, again, I want to suggest the readings for comparing group techniques. It's the Palin book. Well, we basically covered majority of the Palin book, apart from linear regressions. So it's across all 5 of the chapters, 7, 16, 17, 18, and 19. For Andy Field's book, it's the first 1/3 of the chapters, so 6, 7, and 8.